All right, let's get into this substitution problem. This is like heavily, math intensive, plugging in, solving for x, plugging in, solving for y. But visually, the more you understand visually, the more you're going to remember the expected type of solution. So what I visually am picturing in my mind is a parabola that opens up and a parabola that opens down. I know for sure this second parabola has an intercept at 14 and opens down, right? Like that's not a difficult graph to picture. It's a reflection of 14 units. This one's more difficult. Its y-intercept is down at -10. And then I don't really know where the axis of symmetry is. All I know is that it opens up. It could be on that way, it could be on that way. I'd have to do some math, really. I have to do -b over 2a, but b is 0. Oh, so it is right at 0, at -10, and it opens up. I could erase all of that right now. So actually, I have a pretty good visual of this, of one being up at 14 and opening down, and one being at -10 and opening up. Now, this is just a quick sketch of what I'm picturing in my mind. What I know is I'm looking for these points of intersection. When you solve a system, it's asking, where do these two things cross? So I'm thinking, based on my knowledge about graphs, is that there's two intersection points. But we talked last week about how sometimes a parabola and another parabola never intersect. So when we did this last week, if our answer was imaginary, it was no solution. It was this type of situation. We also last week did a couple where it was like a parabola and a line, and there was only one point of intersection. Right? So that's what we're working on, just as a reminder. But how do you do substitution? This one's a nice setup. We had like 3 of these, and one of them was set up like this, where we could just take the y out and we plug all of this in. That's the substitution we're looking for. Sub for 0 and solve it. So let's see little hand raise if you finish the problem. All right, I'll give you guys some more time.
I have a hard time knowing where to start.
Make it equal 0. You mean to get this far?
No, I know. I understand that.
Okay. I would add x squared over. That's what I would do. Desmond, did you raise your hand? It must have been Flynn. Flynn, what was your question? You're not sure if you have it right?
I don't know. Do you stop once you get all the two axes?
No, you find x and y.
Oh, you want to find y too?
You find y too. Kenzie, did you find x and y?
I found X.
Yeah, go ahead and continue. Find y. Yeah, you can either factor it or do the quadratic formula. Sometimes you can solve by square rooting. It's really like any strategy you have in your toolbox to solve it, you use. We've been practicing solving for like a month now. Do some math. I don't think it is. You got a decimal? No. I love a good math question. I'm not mad. If the conversation's about math, we're good.
You kind of exploded on your content.
That's the thing, I don't even have a pen.
You had a fun last week. It's good. No, you blame me. You gave it to me right away.
All right, so set equal to 0 in this thing is 0 equals 1.5 x squared minus 24. I see 3 things we could do to solve this. Part of me to solve this would add 24, divide by 1.5, and solve by square rooting. Does anybody see that method when you look at this? A couple of you. Feel free to use that method. I could also divide everything by 1.5 and then factor it, because I know that 24 divides by 1.5. Does anybody else see that 24 divides by 1.5? No, so that strategy is not for you. I could also use the quadratic formula because that always works. How many people are going to use the quadratic formula because that always works? Okay, good. Do it. Oh, you did? With this 1.5 here? Love it. X factor works.
I think that marker needs to be found.
Yes. Is it this right here? No, I'm doing this right now, but I will come by. Using the quadratic formula, you should get to 4 and -4. Or we could try using square root method, or Flynn says X factor method works as well. I'm going to show the square root method just because we haven't done that in a while. That problem's not done. You have to still find y. Lily, did you raise your hand on square root? A couple of people did. Oh, you did? X is positive and -4. And then, so Flynn, you went ahead and you did what? You did
1.5 times 24, which is negative 24 times 1.5, and you put it over 0, and then you get 6 and -6, and then you divide those by 1.5, 1.5, and you get 4 and -4.
Okay, so this is like a very cool summary of, you know, 3 of the methods. Everything besides completing the square was done here. So when it comes down to quadratic, you have all of these tools and you get to pick which one you like best if the question doesn't tell you. So you could pick the formula, you could pick the square root method, or you could pick X factor method. They all come up with the same exit. So. Everybody, we're going to try right now, and this is required. I will take a participation point, if you do not stand up. You are going to stand, share, sit right now. Everybody stands up. You personally share which method you like best, and then you sit down.
I like square root. Why are both of your calculations?
Front of x squared. It's not negative x squared. It's negative 1 times x.
Both numbers.
Why?
Oh, wait. 2 times 1.5.
Right.
Yeah.
You could.
All right, we are not done yet. We have to find y. There is something very tricky about that second equation. Y equals negative x squared plus 14. This is a commonly mistaken problem because people read this as negative x squared, where really it's negative 1 times x squared. Consider if there was a 3. Consider if it was negative 3x squared plus 14. Wouldn't you do x squared first and then multiply negative 3 after? Yes, you would. The negative 1 is the same way. You square the x first, you multiply the negative 1 after. So when I plug 4 in here, it's 4 squared is 16. 16 times negative 1 is negative 16, and I get a 2. Does it make more sense with the 3, Calypso?
Yeah.
This one's so much easier than the negative when there's like a number with it. So the positive 4 resulted in a 2. Now we'll do negative 4. This is to find the y value since we already found x. Oh, these are both supposed to be negative 2. Negative 4, negative 2, positive 4, negative 2. Did anybody plug into the top equation and get negative 2?
I plugged into both.
Nice. Nice. Kenzie, did you plug into the top or bottom? You put 4 in here, or did you put 4 in here?
I did both.
Oh, both of them did both to double check. Should we put it in Desmos to like triple check? No, nobody is curious to see where these two things cross. No, ready to move on. We better check that handout from Friday. I'll get the pumpkin passes out. Get your handouts out. If you finished it, I'll give you a pass.
Yeah, I got one.
Yeah. Did I give you one on the way out since you finished?
He did do it on the board.
I fully remember Flynn's participation. He did a lot. So I'm not gonna like sell you out today, but you do need to make sure you don't lose your
I did that with a pencil with a pen on it, then I did red pen, then I did a highlighter, then I did with a pencil and a pen. That's stupid. Okay, Friday. What Friday? What Friday? How did I do that? Did you? The thing to get the slip. Yeah. How do you know what's up? Oh, it's good.
Those should all be colored in.
How much did you write for this one? He's cold. He might as well retire.
I put that one in my
That's not rough fit.
It's not bad. Can I fix it to get my pass? Because I did work on it on Friday and it helps on the
I didn't know what they were doing.
Don't ever blame anything on Tyler. Why are you blaming on me? No, he's not cool beans at all. You don't understand when it's supposed to be.
We got that though, yeah. But like inside of prehistoric can't take looking. This way's faster. They just be sad. Small stuff. It's that eyes getting farther apart each and every. We call them what? The mighty queen. Why is there a time for 226? Nah. Where is it? Second year.
I don't know.
And if it's wrong, just take it. You'll be fine. Like she didn't get slipped because she was not wrong. So how did you? That's on me. You have to get it right. You gotta get it right the first time. Everything but one, and then we got the three.
What happened? She looked at my shirt and yeah, she's been doing that for everything. How'd you decide to do it? Nothing, you didn't do it. Why are you lying?
Credit for the assignment. Only the people who took the time to finish it credit that came, participated. If you came to the board, you're getting extra credit. You're only getting passed if you finish it correctly.
It's probably not correct again.
It's still not right. We're gonna go over it right now. So if you're confused, let's go over it.
Exactly. Nobody should have passed at all. Like literally on Friday, it was like it was a good assignment.
Why? You just lost a little.
Because not everyone is helping at all.
All right, let's get into today's work now. 3.7.
Hey, how come you have a tie set? Tie.
Okay, you do not need to write these down. You already have these written down. This is on the handout you just had up. You can write it down if you want. This is talking about a system of inequalities. If you want to write down the page numbers, if you want to write it down to go through what we talked about Friday, or what you guys looked at Friday, write it down. And then we're going to graph a system of inequalities today. Okay. So when you have two inequalities to graph, so full upgrade from one inequality to two inequalities, you graph both inequalities. The area where the shading overlaps shows solutions. When you're graphing the inequalities, remember, if it's this symbol or this symbol, use a dash line. If it's y is more or y is more than or equal to, shade up from the y-intercept, color the entire area. For less than or equal to, shade down from the y-intercept. This you did not write Friday. If you want to write it now, you can. And then these are the two that we're going to graph together right now. If you have graph paper, do it on graph paper. If not, just do it on notebook paper.
Do I have graph paper? No. It's like graph paper. Your whole thing's made of green graph paper.
All right, so what we have is a system, and it's composed of a linear and a quadratic. For the linear, you have to remember how to graph y equals mx plus b. For the quadratic, you have to remember how to graph a quadratic. There's a couple of strategies for graphing your quadratic. On Friday, you guys discussed together doing negative b over 2a and finding an axis of symmetry. Here's some page numbers if you want to look at the book while we go through it. Find a graph. All right, so as a reminder, to graph a straight line, you use the y-intercept and the slope. So you begin at the b value. And then you're going to move the slope, which in this case is just 1. So we're going to move up 1 over 1. So I'm beginning at negative 8, and I'm going up 1 over 1. And then I'm going to connect with a dashed line since it's not equal to. And since it says y is less than, I'm going to shade below. Notebook paper. So that's a review of graphing a linear inequality. Now for the quadratic. And what you want to do is you will get confused if you don't shade before you start the second line. Completely finish one of them before you move on to the next. Sometimes students they decide they want to do both shading at the same time, and the shading ends up in the wrong spot. So I completely finished the linear one before I go to the quadratic one. And it might be two quadratics. It's not always going to be a linear and a quadratic. All right, so I'm going to graph y equals x squared minus 2x minus 8. So I'm going to do negative b over 2a. And I get x equals 1. That's the axis of symmetry. Right there. And then I'll plug that in. And I get negative 9. So now I know the vertex is at 1, negative 9. And I know that a equals 1 here. So I know this is congruent to the parent function. So from the vertex, I can go up 1 over 1, up 2 over 4. I also know that the y-intercept is negative 8. And I'm going to connect with a dashed line. A lot of dashed lines going on here. Maybe I'll make it a little thicker. And this one is y is greater than, so I'm going to shade up. Now, this tiny little area where the yellow and the blue overlapped, that's where the solutions lie. And that's the gist. Two graphs in one place, find where they overlap. Your assignment today will also have this, I think there's 3 questions like this over here. So when everyone's ready, I'm going to zoom in down here. And then the graph, and then this problem is all you have to work on today. And actually the assignment's online to save you a little bit of work in the graphing. But what it will do is it's going to give you multiple choice graph, and you have to know all the steps to pick the right one. Mm-hmm. I don't know if it's assigned just yet. Yeah, get a computer if you don't have one. This is the second type of problem. So the first type of problem is to graph, find where they overlap. The second type is to determine if a point is a solution. In order to do that, you plug the point into both inequalities, and it must be true for both. So in this example, is 6, 0 a solution? So we'll test both. That's x and that's y. So I'm going to do is 0 greater than or equal to 2 times 6 plus 3. Is 0 greater than or equal to 12 plus 3? Is 0 greater than 15? No, it's not. So 6, 0 is not a solution. And so that means this point would not be shaded. Bless you. So if it's not a solution to either one, you say no and you move on. I'm not even going to bother plugging it into the second one. It has to be true for both. So it might feel like you have a long assignment, but the graphs are already graphed for you. You're looking for details like dashed lines and shading. And then the other ones are plugging in. So, and they are the same problems on paper if you like to see it on paper and online.
What section is it?
3.7. Okay, let me know what questions you have. 2 checks. Go to Big Ideas Math.